Real now.
Hello, everyone. Thank you for joining us today with Go Singapore, and we hope you are keeping safe and well wherever you are tuning in from. Both our speakers are based in Jakarta, while the rest of us are from Singapore. So I'm Jiaxing from the Google Developers Relations team. And before we begin today's session, let me briefly introduce who we are and what we do. Dian is based in Singapore. Yeah, so I think we have only Bilal from Jakarta. Welcome wherever you're tuning in from. A really short introduction to Google Developer Space. It's a platform for developers and startups from around the region to learn and connect with one another. And we want to empower and connect the community to our people, programs, network, and technologies. And we are really excited for today's session with Go Singapore once again. I think everybody, you will be familiar with them. You see them every month on our YouTube and Facebook pages. So without further ado, I'll hand over to Abel from Go Singapore team to share more about today's speakers and sessions with us.
Hey, hello everyone. My name is Abel. Welcome back to the August edition of GoSG. So this time we have two people who will be presenting, Dian and Bilal. Firstly, I'd like to thank the team for organizing this. So it'll be Teck Chun, Stanley, Jiaxin, and me. After this, right, during the breaks, please feel free to join Gather Town. We'll be sharing the link in the YouTube channel. So please feel free to join Gather Town to talk to our speakers or interact with other participants. And without further ado, our first talk will be by Dian. We'll be talking about avoiding gotchas in Go runtime behaviors. So he will be sharing all the interesting behaviors of the language from how the language is designed, and it'll be from his real life experiences facing bugs and digging through documentations, GitHub issues, and tech talks. So hopefully you can learn something and then you avoid facing these gotchas on your own in the future. So without further ado, let me hand over the stage to Dian, who will be presenting.
All right. Hello. Hi, everyone. Can you see my screen? All right, cool. Okay, so hi. Let me start with some short introduction. My name is Dian. I'm currently a software developer at Acronis. I'm mostly working with Golang, Elasticsearch, and a little bit of Python every now and then. Allow me to introduce briefly about Acronis. So Acronis is a leader in cyber protection. It is founded in 2003 in Singapore, and currently it has a dual headquarters both in Switzerland and also Singapore. In Singapore itself, Acronis has one of its biggest R&D centers, and it employs more than 1,600 employees globally across more than 30 locations. It provides cyber protection features, including platform and a set of protection services on top of it. If you're interested to know more about Acronis, feel free to visit our website and you'll be able to find out more about it. But one thing for sure that I want to share with you is we love Golang and we are building a lot of exciting stuff with Golang. And that is part of the reasons why I'm here today to share a little bit about Golang with all of you. All right, so without further ado, let's start with the talk itself. So I'm going to share roughly 5 topics, and I kind of give some hints and short title for each of them, so you kind of get intrigued about each of them. So let's start with the first one. So as the title suggests, it is a question on whether the program will halt or will it stop when we run it. So let me briefly explain what the program is doing here. We have a test function here. It's just initializing an integer called a, and then within a loop, it does some computation. So you can think of it as just a simulation of some computation function, right? And in the main function itself, we start by setting the go max procs to 1. And after that, we print a start string, and then we spawn a go routine. The go routine is doing nothing, but keeps on looping in a tight loop, calling the test function again and again. So it is simulating a heavy computation. After that, the main program will sleep for 100 milliseconds, and then it will print done string. So the question will be, if we run this program, will it stop or will it keeps on running? Yeah, unfortunately, it would be nice if you can leave some comments, or yeah, I'll give you some time to think about it. Even if you don't want to leave comments, it's fine, but just try to guess or think like whether you think the program will halt or it will keep on running. Yeah, maybe I kind of give the answer away by putting a GitHub issue here. There's an issue, so it should be an issue. But the answer to the question is it depends. The answer to this question is it depends on your Golang version. For example, if I run this, the answer is yes, the program will stop. But in my machine, I'm using Go 116. So I'll switch here. So I'm on Go 116, right? If I go to halting, this is exactly the same code. We have a test function, setting Comex box, looping and triggering the function, sleep for 100 milliseconds, and then print done, right? If I run it here, it'll be the same thing, right? It will exit. But I have another Go version in my machine, which is 1.13.15. And if I run the program with this, now the behavior is different. It prints start, and after that, it just gets stuck. Means it will not halt or it will not exit from the program. So the next question, of course, will be why different behaviors between different Golang version? And in order to answer that, let's revisit a little bit on Golang MPG model. So as we know, in Golang, we have a very powerful features called Go routines that enable us to do concurrencies very easily. But behind the scene, actually, the runtime does a heavy work of the scheduling. So in Golang, they model it as something called MPG model. The M stands for machine, or you can think of it as your OS CPUs. So how many CPUs that you have. The P stands for process, and you can think of it as a scheduling context, or some people call it a run queue. So basically, all your Go routines, which stands for G here, will be queued up behind a run queue, and its run queue will be assigned to a CPU in your operating system. So in this diagram, you can think of the machine has two CPUs, and we have two run queues. And for the first run queue, there are three Go routines. The first one is running, and the other two are being queued. And for the second run queue, there is one Go routine running and one Go routine is in the queue. When this Go routine, let's say, finish or context switch, it will be relinquishing the CPU, and the next Go routine can take up the CPU. And when the Go routine is ready, it can come back to the queue again, waiting for its turn. In traditional OS scheduling, we know that operating system can do preemption, right? It can force a process or a thread to relinquish CPU so that the CPU can be taken up by another process or threads. But in Go scheduler, in most cases, they are doing it in cooperative manner. It means that the Go scheduler, in most cases, will not force a running Go routine to release the CPU so another Go routine can run it. They are relying on something called checkpoint. So basically, there are codes in Golang that can signals the scheduler saying that, hey, you can do a context switching here, and another code can take up the CPU. There is no exhaustive list of in the Golang official documentation on this possible checkpoints, but if you look through online across the GitHub issues, documentations, or some tech talks, some people are listing the possible or the checkpoints that are already known. The first is by invoking runtime.goSCHED explicitly. This will trigger your scheduler. And when your Go routine is doing syscall IO, of course, it is safe to do context switching. When you're calling a non-inline function, or to be precise, is when your stack grows. A little bit of extra information here. Another interesting part of Golang is each of the Go routine has its own stack, and the stack can grow, as opposed to the traditional stacks in OS threads, whereby the stack cannot grow, but the stack for Golang Go routines can grow because it is being managed internally by Go runtime. And The next one is when you're calling sleep. Of course, it's safe to do context switching. And when you're doing channel wait or mutex, it's also safe to do context switching. So coming back to our original code, as you can see, we are specifying go max procs to 1. The go max procs is actually changing the run queue. So no matter how many CPUs that I have in my machine, we only have one scheduling context. It means that at most, there is only one go routine can run at any point of time. And when we sleep here, it forces the main program to relinquish the CPU, and the go routine that we spawn here will take up the CPU. And because this is a tight loop and it just keeps on looping, it means there is no way for the Go runtime to context switch back to the main program. And this is the cause that this is the one that causes our main Go routine or main program is unable to exit. Once it finishes this line, it will never hit this because the only run queue that you have is being occupied forever by this Go routine. So this is a problem because if we have a tight loop, there is no possibilities for context switching to happen. And because of that, Go team has been trying to improve their scheduler, and they have added preemptive mechanisms in its Go version. And from if you use Go version 114 and above, you will not hit this issue because they are already able to preempt or force the context switching when it detects a tight loop. The GitHub issues is 10958. You can just look into it for the details if you're interested. As you can see, the issue is filed in 2015, but it is a long discussions and it is going up to 2020. So it is a long process of improvement in Go runtime until the point that now they are able to preempt a tight loop. But you might say that, hey, this is a bug. Who will code this loop that will never finish? It is invalid. Yeah, you kind of have a point that this is an exaggeration just to kind of demonstrate what could go wrong with this runtime behavior. And in fact, if you look at this issue, I take this snippet from the issue itself. Someone proposed the easy way to reproduce the issue. In real life behavior, or in real life programs, what is more probable to happen is if you have a long running computations or heavy computation Go routines, you might delay your garbage collector because in Golang, one of the stage of the garbage collectors requires stop the world, means it needs all the Go routines to go to sleep before it can perform the job. And if you have one Go routine that is long running doing computations and the Go runtime cannot preempt it to context switch, means all your Go routines cannot run because it's waiting for that one Go routine to go to sleep and then GC can run. So the more possible behavior that you can observe is your GC pause is longer than what it is supposed to be. And yeah, it comes to the conclusion that whenever possible, try to use the latest Go release because in its release, there is a lot of improvements being added into the compiler itself that can improve the performance in one way or another. And a little bit of extra, we talk about Go max procs, which is by default being set by Go runtime to the number of CPUs that you have if you don't set it explicitly. But the question is, if we are in the environment like Kubernetes, whereby we can set a quota, right? So for example, if we set a CPU request to 1 and CPU limit to 2, and then the service is running on top of host with the CPU count of 6, what will be the Go max procs that is being set by the runtime? And the answer to this is 6, because for Go runtime, they are not aware of the quota that is being set by Kubernetes here via C groups. They're only aware of the CPU counts on the machine itself. In majority of the cases, this is fine for you to have one CPU and then 6 run queue trying to get the CPU because the OS itself still can do time slicing for you. But there is an interesting repositories by Uber called AutoMaxProcs. It is basically saying automatically set Go max procs to match Linux container CPU quota. So if you look through the repositories, they are providing a benchmark to show that when you don't use the default GoMax procs in environment that has CPU quota, you can have a better performance. Means that in this case, you should set your GoMax procs to 1, and it might yield you better performance in some cases if performance is very critical to you. So I put a word consider. So consider to use this if your service is running in Kubernetes or any environments that utilizes C group or quota. All right. So yeah, that is the first one about CPUs and scheduling. Next, let's talk a little bit about memory. So again, let me explain a little bit about the program. We have a function called test_alloc, which is just doing memory allocation of X megabytes. And then we are touching the memory in some of the bytes to make sure that it is dirty, so compiler cannot do any optimization on it. And in the main program, we are calling it 3 times, 100 megabytes, 200 megabytes, and 300 megabytes. Okay. And after that, we call GC explicitly to trigger the garbage collector, just so that we don't need to wait for the actual garbage collector to happen. And then we call a go routine to print the memory statistics every 1 second just to observe the memory behavior. And in the main program, we will sleep for 150 seconds just to simulate a long-running process and to allow us to observe the memory behavior. So the question will be, what is the memory observed by this program? And again, the answer is it depends on your Go version, but this time it also depends on your operating system. The more interesting behavior will be on Linux operating system. So for that, I will switch to Linux VM. First, let me show you. This is exactly the same program. We have a test_alloc function. We call it 3 times. We trigger a GC, and then we print the memory statistics every 1 second, and then we sleep for 150 seconds. Okay, and let me clear the screen. To demonstrate the issue, I will use Go 113.15 again. Oh, just to brief you so you're not confused when I'm switching screen. I have a screen. Oh, sorry. Oops. Now I can't exit. Okay. I have a screen session called GoDoc, which I will use to run the program, and then my main screen I will use it to monitor the memory. All right. So I will go back to GoDoc. Let me run this. Okay. So as you see, because we trigger the GC, the heap in use is 0 megabytes. The heap release is 767 out of 767, which was requested. So technically, it should mean that our Go program is not holding much memory anymore, right? So let's switch back here. I run top. If you see, this is our main program. It's still holding 621 megabytes of RSS, which is kind of contradicting with what Go memory statistic reporting. If I switch back, oops, sorry. There is a screen on, there's no screen to resume. Okay, sorry, give me a minute. Let me just kill it. Okay. Sorry about that. Demo. Memory. Right, we are back here. Let me just run top first. Okay, there's nothing. So the question will be why the memory reported by Linux is different with what is being reported by Golang memory statistics. And to show you the difference, if I switch to doing this, from memory statistics of Golang, it is the same thing. It is saying that heap in use is 0, heap release 767 out of 767. Now, if I go back and I run top again, here is our main, but this time it is only occupying 20 megabytes, which makes more sense because the 600 megabytes that was requested has been released to operating system. So this is better monitoring results. So to answer that, it is because we can see the release note of Golang 116. Here it is saying that, give me a minute. Here. On Linux, the runtime now defaults to releasing memory to the operating system promptly using metfeed.neat, which is the one that we set explicitly with Go debug just now in Go 113, rather than lazily when the operating system is under memory pressure using metfeed free. So what happens is, before or prior to 116, Golang default system call on Linux to release memory back is something called metfeed free. Metfeed free behaves in the way that a process release a memory back to operating system, but it says to operating system, hey, you can take it back if you want to. Means that operating system can choose not to reclaim back the memory. This happens when your system is not under memory pressures, because in some cases you want to keep the memory so that you can reuse it. By doing so, you don't need to make another syscall to request the memory in the future. This happens for Go 1 up to Go 115, whereby the operating system does not detect any memory pressure because we are the only service running there, so it does not reclaim back the memory. So that is why we still observe 600 megabytes in the RSS, because from operating system perspective, our service or our Golang program is still holding that 600 megabytes, whereby in fact, the 600 megabyte is free and can be reclaimed. And this happens that in production, you might observe that, hey, my service is utilizing 2 GB and it never goes down. Where does the 2 GB go to? I mean, do we have a memory leak or some program is holding into it? And then you run a pprof and you see that there is nothing being held. The pprof shows nothing. That is because even for the pprof, it will not detect this memory chunk. Pprof is only reporting memory that is still alive, means it is still being used by your Go program. For memory that is being released but not reclaimed by operating system, it will not show on pprof. So it is double confusing now, because the Linux say we use 2 GB, the pprof says that nothing is being used. This is because of this system call. And to avoid this confusion, Go runtime revert back to use metfeed.neat as the default, so that whatever that you release to memory will be promptly reclaimed back by operating system. Sorry. But if you want to still use metfeed free, you can still use Go debug, metfeed.neat equals to 0. Then you will get back the metfeed free behavior in Go 116 and above. All right. So again, it comes back to, whenever possible, use the latest version of Go, because it will help you to have the latest behavior, which is better in my opinion, and it will avoid the confusion in terms of monitoring on Linux. And avoid big memory allocation whenever possible, because this is the one that might lead you to out of memory error and your process getting killed, because the operating system is actually not reclaiming back your memory. And monitor your service resource usage. If it shows 2 GB all the time, or even 8 GB all the time, something is wrong if you know that your service is not doing caching. So probably something else is happening behind the scene. All right. So yeah, that is a little bit about memory. So let's switch to the next one, about race condition. Okay, sorry, give me a minute. We have a program here, which is calling a reset function. So, okay, I'll declare a global variable a and b. It's just that I omitted from the snippet. So reset will set a to 0 and b to 0. And f function will set the value of a to 3 and b to 4. G function will just print them out. In the main function, in the loop, every 200 milliseconds, we are calling reset and we are calling f to set the values in the coroutines, and we are printing them, right? If we run them, 0, 0, 3, 4, 3, 4, 3, 4, kind of makes sense, right? Because it is either 0, 0 or 3, 4. Yeah, I'm trying to find the race condition, but since it's a race condition, it's not trivial to find. Yeah, you have to run it many times in order for you to hit it. Sometimes you might not even hit it. Let's run one more time. Okay, not that, but you can try it later, but I'll just show you why this is a race condition. If I go to race.1, right, so this is exactly the same code. You have AB, you're resetting it, setting it, printing it within the loop. Now, if I run it just as is, it's doing the same thing. Nothing happened. But if I add the flag brace, it will call me that there is a data race. Read at main.go26, which is this guy, which is trying to print a variable, and previous write at main.go line 16, which is this, which is setting the value. So at a glance, it does not look like a race condition, but it is a race condition because in Golang, when you have multiple coroutines trying to manipulate or access the variables concurrently, there is no guarantee that they will observe the same order. This is, yeah, maybe easier for me to just open this. This is an official Go documentation. They call it Go memory model. Yeah, this sentence summarizes everything. If one coroutine executes A equals to 1, B equals to 2, another coroutine might observe the updated value of B before the updated value of A. This happens because the compiler can do reordering within a coroutine as long as at the end of that coroutine, it is still consistent. What it means is A equals to 3, B equals to 4 could be reordered by compiler in some scenarios into setting B first and then setting A. Because within this coroutine, setting A first or setting B first does not have any difference. It still leads to the same consistency as the end of the coroutine. Go runtime does not care that another coroutine is trying to access them, and it simply means that another coroutine could observe a different ordering. So that is why you should use the synchronization primitives like locking or use the Go channel if you want to access and modify data concurrently across coroutines. And yeah, it leads us to the points that try to enable the race detector in your CI pipeline so you can detect race condition as early as possible and fix them. And some race condition might seem very subtle and you might think that, hey, maybe this is not a race condition, but it is very unlikely for race detector in Go to be false positive. If Go race detector says it's a race condition, fix it. And bear in mind that the race flag only can trigger the race condition if that path of code is getting executed. So don't expect it to be able to do static analysis on your code and find a race condition in some function that is not getting covered in your test. So it also means that your test coverage must be big enough such that you're confident that most of your critical path has been covered. So you're confident that there is no race conditions happening there. Okay, All right, so let's move to the next one, which is actually not about runtime, but it is just interesting to me, so I added it to the talk. Probably from the title, you kind of can guess what is happening here. I'll briefly explain it. So basically, our program, this is a simplified and modified version of our actual code that hit this problem long time ago. I simplified it just to capture the gist of it. So we are trying to build some cache from some external service which supports some kind of pagination. So we need to pass like the page token to know that which page we are currently on. We start with an empty page token to signify that this is the first page to be requested. And for its request, it will return the results for that page and the next page token, an error. And for the results, we just populate it into cache. And if the return page token is empty, means there is no other page. If it is not empty, means there is a next page to be loaded. So we loop back and request next page again. And from this, you can see that the page token here, which is supposed to be the next page token, is the same variable with the page token here that we initialize on. So it is shadowing the page token here. So what happened is the page token in the next loop will be empty again, and we are back requesting to the first page. So if we have more than one page, we will get stuck forever requesting the first page because the page token will keep getting loaded back and use the page token value here. It leads to a very weird bug because you might start thinking that, hey, why my program never finished? It keeps on getting stuck in this loop. What is happening? It can be easily avoided with linter. One of the good linter out there, folks, Golang is Golang CI lint. It supports a lot of linter, and specifically for shadow, you can use GoFet, but it is not enabled by default, as far as I understand. So you need to set the check shadowing to true for GoFet, and if you just run it, yeah, it will tell me that page token at line 17 is getting shadowed by line 19. So this is another good thing to be added to your continuous integration, enable your linter so you can catch this kind of problem early before it becomes some weird behavior in your production. Okay, so yeah, enable linter and only allow no lint when comment is provided, because I know it is very tempting to just remove the linter for a particular function so that we don't need to fix the linter warning. But in most cases, it is good to fix your lint warnings as early as possible. Right? Last one. It is about finalizers. Finalizers is a very, I would say, interesting feature in Golang. In language like C++, we have a destructor, right? You can define a destructor for a particular object such that you can run some kind of logic when the object is getting destroyed. In Golang, we have something similar but kind of different called finalizers. Instead of defining something to be run when object is destroyed, you can define some logic to be run when an object is garbage collected. And because it is being run when it is being garbage collected, means it is not deterministic, because you can't tell when an object will be GC. Even when your object is already out of scope, your GC might happen sometime in the future, so you can't really tell when it will happen. One of the use case of finalizers is actually in the Golang source code itself, in the file unix.go. If you find for set finalizer, here. So for file descriptor, Golang is adding a final line of defense to avoid file descriptor leaks. So it's saying that when a file descriptor is garbage collected, means it is safe to close the file descriptor. And then because we already have this, then you might think that, hey, Go already settle it for me, means I don't need to close file descriptor, right? Then let's try it out. This is coming from this article, Tragedy of Finalizers. You can read through it if you're interested. Sorry. Basically, what it's doing is it is creating a temporary directory, right? And it just loops through 2000 times. And for it to solve it, it will create some file. And at the end of the loop, the file descriptor for that particular file is no longer alive, means it will be GC. Then you might think that, okay, the finalizer will kick in and it will clean it up and it should be fine. But the problem is, if you're in Linux, so this is exactly the same program. We loop through 2000 times, create a file, and not doing explicit close, right? And if I run it, it crashed because of too many open files. This is because, as we know, in Linux, we have a limit of the open files, which is default to 1024. And the thing with this finalizer is, because, as mentioned, it is not deterministic, it requires the GC to kick in. And because this loop is doing nothing, it runs so fast that there is no time for GC to kick in to clean up the files, and it hit the upper limit of the default Linux file descriptor limit. And yeah, so the take-home message is always call close or the equivalent, because we know in Golang you also need to close for example, IO read closers, and for sure for file descriptors. Call it explicitly to prevent leak. And the finalizer by itself is a cool feature, but there's a reason why it is under runtime package. Use it only if you know what you're doing and you're sure that this is the only way for you to achieve the behavior that you want. There are many discussions out there. If you look about finalizers, some people are debating that finalizer is good if you are designing, let's say, an external package. And let's say your external package demands the user to close something when it goes out of scope explicitly. So you want the users to immediately get notified if you forget to close an object, right? You can put a finalizers for the object and checks if during the GC time, the object was not closed explicitly by user, you can just fatal out. Your program will get killed and the user will immediately know that, hey, something is wrong. I used the external package wrongly. But of course, some people will say that, hey, it is not good to fatal out, it is not the right way, and so on and so forth. So some people are debating that finalizers is a good feature and can be used. Some people are saying that finalizers is not the way. And yeah, as it goes, it is a very tricky features, but it is there for you to consider if you really want to use it. And of course, in the context of Linux, try not to open too many files because we have a limit on it. But if your system really requires that many open files, then just remember to update your U limit so you don't hit the limitation. All right. I guess that is pretty much from me for today. And yeah, as mentioned, Acronis loves Golang, and we are actively hiring for Golang developers. If you're interested, feel free to scan the QR codes for particular positions that you're interested in, or you can just go to acronis.com/careers to find out more about the other positions. Yeah, I guess pretty much that's it for me. We'll hand back to Abel or Stanley.
Hello. Nice talk, nice talk. We have
Thank
a
you.
couple of questions from Diraj, but maybe I'll share the question that has maybe some relation, but I think you answered it along the way. So he asked this during the GC when you mentioned object.
Mm-hmm.
So what he's asking, like, what do you mean by object? Does it mean variable?
Yeah, I mean, yeah, you can say because you assign an object or variable. So what I'm saying is when the object goes out of scope, or yeah, you can say when the variable goes out of scope, then it will get GC.
Okay, so he had a follow-up question. So when you mentioned about memory leaks, if you don't close the objects, if you remember.
Huh?
Yeah.
Yeah, you can consider it as memory leak because at the end of the day, each object will need some memory to represent itself in a program. But in the case of file descriptors, it is also file descriptor leaks because as I show in Linux, there is a limit of how many open files. So if you don't close your files, it means for operating system, you're still holding to the file descriptor. So even though you actually don't use it anymore, the counter will just keeps going up. And if you hit the limit, then you will just get killed by the operating system. So it's also a file descriptor leak in this particular case.
Okay, so I think we'll go to the more general questions he had.
Mm-hmm.
So one of the does it fit? Okay, yeah.
I'm
So
learning to
maybe just
program in
general advice
Go.
on if you are starting on Go, right? What would you recommend someone to build or try out or?
Okay. Uh, okay, maybe not specific to Go, but if you ask for suggestion, I would say that you can start by trying to find any like publicly available API and build something on top of it that might interest you. For example, if you're interested in games, you can find the publicly available API in games domains like, I don't know, like Dota statistics or some statistics, and you can build something interesting on top of it, like build some aggregates of statistics. I mentioned as a backend developer. Yeah, it's still applicable, right? Because you're calling API calls, it's still a backend. But yeah, you can visualize it nicely if you have some, front end programming too. Or you can always try to implement some nice algorithm of data structures back to the basic. It's also interesting to implement those things in Golang and see how you can use Golang to solve algorithmic problems. Yes, follow up. What kind of topics or concept I must focus on? Okay. If you're asking explicitly for Golang, then I would say start with the Go tour where Golang introduce all the key concepts. If you finish it, I think it's already a solid start for you, and you should be productive enough to build multiple stuff. And when you hit the issues, it will trigger you to explore more, and you will start finding articles, GitHub issues, Stack Overflow questions. Then for there, you will have the opportunities to learn a more advanced stuff. I hope it helps.
Okay, yeah, I think he said he thanks you for the answer. Yes.
You're welcome.
So we'll go to the next question from Saga. Since Go allows parallelism by using Go max procs, how do I know the right number of CPU cores we should assign to our application in order to provide the best performance?
Okay. If you're asking about performance, question, the final most people will say do the performance test, then you will figure out the answers. But in general, the default by Go is good enough, which is the Go max procs will equal to your number of CPUs, because it makes sense, right? If you have 8 CPUs, means at most you can run 8 Go routines in parallel at any point of time. But in some situation, if you run on top of some virtualizations like Kubernetes, you might have less number of CPUs than what is actually available in your host machine. Then that is why I show the Auto Max procs, which can help you to automatically detect the right Go Max procs depending on your quota that you set. Look through the repositories; they have a nice like benchmarking on what is the relation if you have like, let's say, X CPU, but you set your Go Max procs as 2x, or if you set your Go Max procs as X, and if you set your Go Max procs as some value. So they have a nice chart that show you the effect of GOMAX procs with regards to your actual CPU. But in general sense, I would say in most cases, just go with the default by Golang, which is GOMAX procs equals to your number of CPUs in your host machine.
Okay, let me see. There are no more new questions, so maybe we'll just wait a while to see if anybody has anything. But after this, we'll be going to Gather Town for a quick breakout session where you can talk to our speakers through the Gather Town interface. So the Gather Town interface was actually shared in the beginning of our chat, but I'll share it again. So you guys just click on it and join. We only have about 7 people in now, so just feel free to join. You can speak to our speakers there. You just walk around, you can find Dian and the upcoming speaker Bilal. Okay,
Right.
let me see. There are no questions. Okay, so thanks for the talk, Dian. It was very, very informative and very interesting to see the presentation halfway going over to the documentation and then reading the documentations and everything. I think it was very helpful. So we'll all break out for the Gather Town for a while. We'll make an announcement in Gather Town to come back here again for the second talk. So in the meantime, please feel free to go over to Gather Town. We just posted something there. Okay, thank you.
All right. Thank you, guys.
Hello, hello. We are back, but just give us a couple of minutes to do some backstage preparations. Hey, folks. So we are back. Hey, so yeah, hope everyone had a good break. Hope you managed to grab something if you haven't gotten dinner. So yeah, welcome back, everyone. So for the second part of our event today, we're gonna have Bilal, who is who is currently a actually, why don't I let you introduce yourself, Bilal?
Okay, thank you, Stanley. Thank you, GoSG, for having me, for inviting me for this event. Uh, l- my name is Bilal. Right now, I'm working at BTPN Syariah. It's one of bank in Indonesia, Syariah Bank in Indonesia. As a chapter leader. Chapter leader is basically the same squad leader, same with other organization. We call it chapter leader. Yeah, right now. Previously, I'm working in as a software engineer in Tokped and Kudo. Now it's called Grab Kiosk.
Yeah, so for those who don't know Tokopedia, who Tokopedia is, so they are like the biggest e-commerce site in Indonesia. So Bilal came with like a lot of experience dealing with large scale systems. So but today he's gonna give us a very basic talk. So like back to the fundamentals, how we can build good system. Yeah, so yeah, without further ado, I don't think I want to take more of your time, but rather have your talks start. So yeah, thank you so much, Bilal, for joining us. I'm gonna just get my
Okay, thanks, Stanley. Hi guys. I a little bit not used to talk in English, so I'm sorry if I talk a little bit not clear for you guys. You can just put a question if something you weren't clear, and I can repeat it. So today I want to really back to basic. It's like Dian is another end, yeah, in this end, and I'm in this end. It's really for new programmer. Uh, I will go back to basic learning Go language for programmer. So the why. So in my team in BTPNS, all development is still using Java, unfortunately. But uh, uh, I need to expose to Golang. So when Stanley asked me to give talk in this meetup, I need to like uh, okay, I have this need, and then Stanley, and I just need I just do one thing for two things, basically that. So that's the why. I need material to expose Go to these programmers. They had already experience as an experienced programmer, but never touching Golang. What we're going to talk about is primitive type. block, shadows, and control structures, function and pointers, type methods, interfaces, and one of algorithmic talk about divide and conquer. In divide and conquer, we talk also about recursion. Primitive type, if you see in Golang, the most verbose Golang, the most primitive type is one of primitive type, one is booleans. To declare booleans, something like this. This is the most verbose. The second one is the really verbose. Var is run equal true. Create variable, give value true. For flag bool, the zero value for boolean is false. This flag is gonna declared as with type false. It's the same with stop equal false. This declaration take both implicitly give type boolean because the value is false, and give the value for this variable is type variable. Golang have a large number, and then others numeric types. Golang has large number numeric types. There's 12 different types. This type of group has three categories: integers, floating points, and complex type. I never use complex type, so I'm gonna only touch the surface. The integer, if you can see, there are 1, 2, 3, 4, 5, 6, 7, 8 types. It's related to the bytes that represented by the type, and then a special there are also special type like byte and ints and uint. For byte is actually the rename, the other name, the alias name for uints 8. It is illegal to assign, compare, and perform mathematical operation between a byte and uints 8. But just prepare uses byte because that's the idiomatic in Golang. And then integer and unsigned integer. This is different between systems. For 32-bit CPU, it's going to be 32-bit signed integer 32. So integers same with int 32. For 64-bit CPU, it's gonna be signed integer 64. It's basically the same, integer and integer. Because integer int isn't consistent from platform to platform, it is compile time error to assign, compare, or perform mathematical operation between integer or integer 32 or integer 64 without type conversion. Integer, the default integer literal. What is integer literal mean is the value of the integer. For example, if maybe for the next slide, I'm gonna give you an example what I mean by literals. And then floating points. Floating points. There's two, float 32 and float 64. This is the file largest and smallest value. And then complex type. The complex type is actually wait, I forgot to put the complex type. Wait. Complex type, which one? Wait. Okay, this I forgot. This is a complex type. They are real representation and image. There are R and E I never use complex type, but this is the complex type. There's two. There's complex 120 and 64. If the real type is 32 float float 32, it's going to be complex. It's going to be complex 64. If the real type is float 64, is going to be complex 128. If I run this, this the this reflect value, what is the type of this X, is going to be complex 128. Apparently my system is using float 64 for default. Okay, let's back to the, that's when complex type. Next, explicit conversion. As this stated that integer is also for other type. You can compare float 32 to float 64 and the other way around, or float 32 and float. We need some kind of conversion. In Golang, we call it explicit conversion. For example, in X, there's integer type. Y is float with the value of 30.2. Z is float 64. If you want to add X to Y, you need to change the type of X, because type is on type integer, to float 64. And same here. If you want to add and resulting to integer, you need to convert it to, yes, because Golang is static type and hard type. And then var versus this semicolon equal. Go has a lot of way of declare variables. Its declaration style communicates something about the variable is used. It's the most famous. There's the var, the name of variable, the type, and the value, assign, and the assign to value. You can leave the type because it's going to be implicit assigned by Golang, or something like this. If you want to assign X to the zero value of integer, zero value of integer is zero. Primitive type in Golang, there's, you can put multiple value. It's in syntaxes is, if you have experience in Python, you can see it's the resemblance, but the differences is in Python it's actually type tuple, but in Golang it's actually multiple type. It's an actual multiple type. So there are two type, X and Y, with X is 10, Y is 20, and others. You can also put it with different type. You can also put like put all the declaration and variable initialization in on the top or on a certain area of your codes, and put this syntaxes. Go support short declaration format, this with this operator semicolon equal operator, to replace a var declaration that use type inference. For example, this is actually the same with this. Oh, I forgot. This is different value. It's actually needs to be 10. It's actually this same. And this actually, with this you can do this. Oh, forgot. This is actually need to add semicolon. Wait. Oh, just, this is wrong. This actually is semicolon. And then with semicolon operator, you can assign value to existing variables. For example, this variable X is actually had already, for example, this is line 10 in this line 11 in your codes. X had already being declared and assigned and then redeclared. And you can use this. What happened is, it's because X had already been declared, in this line of code, it's only put the value x to 30, update value from 10 to 30. The declaration not here, it already been here. For y, because y had not been declared, there's two process, declaration and assignment. So operator, the limitation of operator, this operator cannot be used to declare variable at package level. You must use var. If you package level, it's in a file in outside of your codes. For example, this code. If you want to put something here, you can use like this. You need to use this because it's a variable being declared in package level. Okay. Oh yeah. Next, primitive. Choose what makes you intent clear. There's two options. Choose that makes your intent clear, the clearest. Make your code as easy as possible to being read from other developers or from the future you. When initializing a variable to its zero value, use var x integer. When assigning an untyped constant for a literal to a variable and to default type for constant of literal isn't the type you want for a variable verbose, use long var start. What I mean by this this saying is something like this. If I want to declare x variable, but it has a byte value, not a default integer, you should use this, right? But instead of use this var instead. It's more clearer. This is more idiomatic too. Because semicolon equal allows you to assign to both new and existing variable. It sometimes create new variable when you think you are reusing ones. Prefer use var, explicitly declare all of your new variable in int. Then use the assignment operator to assign value to both new and old variable. Now using cons. This is using cons. It's let's see in my codes. Is there any understanding cons? Which one? This is using cons. Cons can be declared something like this. It's the same with var cons instead of var, the name of the constant, the type, and the value. This is important if you want to declare a constant. Same with with var, you can use this also. You can group with this the syntax with ID key and name key. You can put expression to in constant. Same with other language, actually, and something like this. So it's actually the same with var. And now let's go to composite type. Composite type is type that have multiple value in its type. The first variable, the first composite type is array. This is how in Golang to declare an array, something like this. You can also assign a value, something like this. And if you want to have a sparse like there, for example, something like this is one. If there's so many zero value in your array, you can put this one, just put 0, and then in index 5 put 4, and then put 6 and next index, and then put all 0 until index 10, and put until in index 10 put 150. You can also use this instead of, for example, this. So the Golang compiler is going to implicitly know that, oh, this is for array integer with size of 3. Go only has one dimensional array, but if we can simulate multidimensional array using this, it's actually there's two array. Each array contain array that have 3 elements, something like that. And then slices. If you come from another language, slices is more like list in Python or list in Java, I think, or factor in some language, C or C++. Slices here is there's no no size, 10, 20, and 30, something the same with array, but no no size. So basically, you're gonna use more using slices than array, because you don't need to know capacity and the length before using the value. In slices, for there's a concept append and capacity. Append and capacity. Let's go back to the codes. Append and capacity. Do I put codes here? Slashing this. Okay, let's see this code. In this code, there's slice share with append. Okay, yeah, just this. This the first declare a slice 1, 2, 3, 4, and then slice from 0 until index 2, not include 2. So if you see this, before it's 1, 2, 1 and 2, because not include what is called not include the end. So for example, 0, 1, 2, only 1 and 2 here. And then see the capacity of the slice. It's 4 and 4. What happened is, if you do this in Golang gonna assign y with the same capacity with y. That's why when you append a y with element 30, it also changes the x. If you see this, the third element of the x array is 3 instead of 30. That's why the memory is being reused in this code. But in this code, let's see, it's different. The capacity of x, y, and z. The capacity of x is 5. Capacity of z is 5. Yep. And the capacity of sorry, the capacity of y is 5 and the capacity of z is 3. What happened is this is the same logic as before, but this is actually something like this. 5, because of the element x is 5 and the offset of z is 2, so the capacity of z is actually 5 minus 2, hence 3 value. So I think what I want to try to say in this is be careful when using slices, because in append, when we using append, sometime Golang will assign you value when you calling append. Okay. Next, slicing. Code. Slicing is the same with Python. This what I like about what Golang. For example, this we slice. This is the same, right? It slice. The first is the start of index. The second is the end of index, but it's inclusive, so it's not actually in end. The third value is actually the maximum. So let's see for this being so if you see this different than this, because y and z have the maximum value of an index, the capacity is different than previously sliced. For example, y capacity of y is 2, is because the maximum of index is 2. So it's going to be like this. Yz is 2 is because 4 minus low, the starting offset is 2, then the capacity is equal to. The same with this actually. This, because the offset is 0, the maximum is nothing, so it's going to be the maximum, the length, the value of x is actually 5 minus 0. That's why the capacity is 5. Next, go back to slice. Next to maps. Maps is being declared something like this: the var, the name, and the type. This is the sign. Oh, this is type. This is the key type, and this is it's actually in. It's typo, and the value is in. Nil map is declared to be a map with string keys and integer value. The 0 value for map is nil. A nil map has a length of 0. Reading a nil map always return nil. Writing, nil is the 0 map. Writing to a nil causes panic. This is example of map, something like this. So the map is actually, the key is string, the value is slices of string. You can do this with literal. Declare and assign variable, like something like this in map. The other is struct. Struct is something like this, is too small. Can you see it? You guys see it? Type, person, and struct. This is actually some kind same with C or C++. Name string, edge integer, and pet string. This is declaring struct. You can do this if you already declared a type person. You can declare fret with type person. Bob person with a literal struct, or with literal struct but with each value is being assigned. Same with this. This is anonymous struct. You can use struct without its name. This is person is struct with name, but pet is variable that have type struct, but it's anonymous struct. The struct is don't have name. You can do this with this literal. Go doesn't allow comparison between variable that represent struct of different type. So you can compare, is it the same or not for two different struct. But does allow to conversion from one struct to type to another if the field of both struct have the same names, order, and types. Order is something like this. Name, age, pet. If you have two struct with name, age, pet, same order and type, you can convert between two of the type. And next, block, shadow, and control structures. Places where declaration occurs called a block. Variable, constant type, and function declared outside of any function are placed in package block. Package block I already shown before. File block is variable, constant type, and function declared inside a file defined and important. Within a function, every set of braces define another block. Now the example, what happened if is there any code for this? I don't think so. Oh. No, actually, this is a shadowing test. The same with Dian had already defined. Sometimes because of the scope, because, for example, this variable x is living in two scope, this scope and this scope, the outer variable x. But variable x inside is actually only reside in this. So this is this is shadowing. So in this scope, this variable declaration is actually shadowing the outer variable. This. That's why this is still, this gonna give value 5, this gonna give value 10, and this gonna give value 10. And this is shadowing with multiple assignment, right? Because what happened is, in this scope, variable x is being redeclared. Why? Because in compile, it because it's already a new scope. When declaring, it should be use this, right? But because it's another scope, it's actually recreate a new variable. This is the shadowing package name. You actually can shadowing package name. For example, if empty is the package name. You can actually do this. And if you try this, it's going to be, there's no print line because it's fmt is actually string. Because of this problem. Shadowing variable, and then if this is the if you see the pattern, Golang is much likely Java and C, but simpler. That's why there's no braces here. and only the expression and something like this. The else if, much the same with Java, the else, and Golang doesn't. This is the you can actually choose between the expression and enter and curly braces because it's actually wrong in Golang. You need to the expression and the curly braces. Scoping variable in if statement. Same with the others. Every curly braces it's another scope, but because this is actually a single command, this actually a single scope. So for example, the end variable is being declared. Is actually known in other else uh, else part. But if you try to use end here, it's going to be shown error undefined end. This is for. Sorry. Another is for looping. This is a complete C style for looping. You know, this is a condition only. So Golang doesn't have while. I think this is you use this if you need to use while. And then for infinite, Golang have infinite for loop. And then for range is actually the same with Python, something like this. Every range have two output, the index and the value. If you only put one value, it's considered an index. One need to note is for range value is a copy. So even false here and the value here is different. It's a different value. So it's being copied. And then switch. This is the off switch. You can do switch something like this. You can declare the variable and put this variable as the label of the switch, and then the condition the value. You can also use unlabeled switch, something like this. It's actually sometimes like a traditional if, right? This is the conditional expression. For example, something like this. You want to break if I mode 7 is equal 0, exit the loop. But what happened is this is only gonna break the switch, not break the loop. So in Golang, if you want to do break the loop inside a switch, use a label break, something like this. But if you ever find this in your own codes, you need to refactor the codes because this is actually really too complicated for a simple logic. The other one is something like this. This is also unlabeled because word length only declaration. There's no label here, and that's why word length is being used this like a conditional expression. Different with this. This is only the value. This is. So for clarity, you should replace with always labeled switch, something like this. Now go to function. Function is being declared something like this. This the parameters, this the return value. If you don't have return value, you can omit this. Yeah, something like this. Golang knows about variadic parameters, something like this. You put 3 dots before this, before the type. When inside, it's treated like slices. Files is treated like slices. So you just put range, something like this. Multiple in Golang also have a multiple return value, something like this. Also in Golang, function are value. It's the same like JavaScript and others language, something like Python. Function type declaration, you can also declare a type of a function. Of function is a type of 3 different parameters that return integer. And you can also put this, something like op map, something like this. You can also put anonymous function, something like this. Function without name. And then closure, because function can be a value, and then function can be declared inside a function. Function that declared inside a function is called closure. Closure suggests that function declared inside a function are able to access and modify variable declared in outer function. Closure become interesting when passed to other function or returned from other function. For example, something. Wait, do I have the example? Something like this. So, for example, sort slice. Slice is a function that accept parameter of function that have 2 parameters then return Boolean value. So something like this. You can sort this. So if you the people slice of people is being sorted by age. So function value interesting if you can use in this way. Or something like this. You can create a calculator that use their addition, subtraction, multiple. You can put it as a value for a map, something like this. And then function return value. For talk about function return value, let's talk about defer first. Basically, defer is being presented also in Dian presentation. That's a logic that being deferredly executed. For it, it's being executed before the scope of the function it's ended. So something like this. For example, something like this. You're gonna defer clause, right? You open the file and you need disciplinely, as Dian had already presented, you need to disciplinely close the resource in file descriptor. Defer clause. But when using closure, it's being more interesting. For example, you create a function get file that return a function. Something like this. There's a descriptor, function, and error. You use something like this and defer the closure. The interesting part is the file inside the function. This file is actually a value that being used, that being declared in outer function in this. And when you call closer like this, you actually close the file. And then pointers, something like this. This is pointers. The n is the address operator. The asterisk is the indirection operator. So for example, if pointer to x is a pointer hold the address of x, if you z plus 5 plus asterisk point to x is actually give the value of x, right? Because pointer to x is have the address of variable x. With asterisk is like indirection of to the memory location of x. And then type, method, and interface. This is the most, I think, the most interesting in Golang, because Golang is actually really different when talk about interfaces, methods, and even types. Declaring user define type with the name person to have the underlying type of struct literal that follow these codes. Oh yeah, also in Golang, but private and public is implicit. If you put the name with capital case, it's public. If using small case, it's private. Type in Golang, you can put something like this. You can put a new new type score, name score is actually type integer. You can also create type of function string that return score. Also something like this type team score with map that contain that map key, string, and the value of score. The method is different. It's actually the same with other language, but the difference is receiver. Oh, sorry. Method and function is the same in Golang. The difference is the receiver specification. This is receiver specification. There's two type of receiver, pointers and value receiver. Go use parameter of pointer type of to indicate that parameter might be modified by the function. They can be pointer receiver, the type is pointer, or they can be pointer receiver or value receiver. Rule of thumb is if your method modifies the receiver, you must use a pointer receiver. If your method needs to handle nil instances, then it must be pointer receiver. If you don't need to update things in the receiver, use value receiver. For example, something like this. The total is being updated in increment. That's why you need to use pointer receiver. In string, you only use the value. So just use value receiver. This is too small. You guys still see kan? Code your method for nil instance. For example, if you have an implementation of 3, you need to handle nil 3, right? 3 that doesn't have any value at all. So something like this. If it equal nil, okay, just give the value of int3 with a value file. If not nil, just something like this. Contain is the same, only check the contains. But the point is here. If you have a method that need to handle nil value of your type, put the nil receiver. Method are function too. is actually the same. Underhood is the same. For example, wait, I thought a function too. Maybe I have. Do I have? Oh yeah, something like this. For example, I have either struct, either type, either have add to. It's actually the same. If I use, actually I can use this and call this. It's called method value. This is a method value. And also I can use the type itself, adder, add to, and use this. I put the object of adder and put here. That's why it's actually the same with put the receiver. Method and function too. And then embedding for composition. The type employee have name and ID. The type manager have employee type and then reports. For some programmer, it's called inheritance, but in Golang, it's actually not inheritance. So, for example, manager contain a field of type employee, but no name is assigned to that field. This make employee an embedded field. Any field or method declared an embedded field are promoted to the containing struct, only promoted to the containing struct, and can be invoked directly on it. Something like this can be invoked directly on it. Wait. Yeah, can be directly on it. That's why embedding is actually a composition instead of inheritance. The why embedding is not inheritance is, for example, something like this. Var eval employee equal M. It's gonna be compiling error because M is actually not type of employee. It's type of manager. But var EOK employee equal ME employee is actually the same. It's okay. That's why embedding is not inheritance. Then we talk about interface. This is trigger interface. The interface type is being declared something like this. This is the type, the name, the keyword interface, and the method, the function of the interface. This being declared something like this: the name, the parameter, and the return value. Interfaces are implicitly implemented. A concrete type does not declare that it implements an interface. If the methods set of a concrete type contains all of the methods in the method set for an interface, then the concrete type implements the interface. So something like this, implicitly implemented. It's different with another language. You need to explicitly declare that I am a type of interface what. Something like Java is implement interface, but Golang you don't need to. Accept interface return a struct. It's basically some kind of idiomatic in Go. When you create a function or a method, create a method that accept the parameters of type interface, and then return with a static type. Concrete type. Now we talk about empty interface. Empty interface is something like this. So for example, var e equal 20, e equal hello, and e equals struct. Why does this can be happen? Because an empty interface type simply states that the variable can store any value whose type implements 0 or more methods. That's just happen to match every time in Go, something like this. So this is type for all value in Go, basically, something like that. The use of empty interface mostly, for example, in JSON. When unmarshalling JSON and then you don't have, you just want to see what the value of the JSON is, you use something like this, map of interface, right? Map, the key is string, the value is empty interface, something in here. But empty interface is here and here. And then use something like this. To save, you don't need to extract the value from the value for your user. You just want to save it, or just put it in other persistent storage. You can use this file interface because file only being inserted, not being processed. Because if you want to process the value inside the interface, you need to have the actual value, the actual type. So in interface, empty interface, there's only it's only hold the value, but doesn't have the type yet. To use in interface or empty interface, you need to put the type of that interface, empty or not. For example, something like this: interface integer. This line of code is called type assertion. So because it's interface, but it interface that hold the value of my integer. So you can use this. But what happen if is actually not of type of my integer? The code is going to panic. So to prevent code from panic, use this instead. E2, comma OK equal something like this. So if the I is actually not of type of integer, is just gonna send OK equal false. So you can just check it. This is a type switch. This is type insertion. This is type switch. So do nothing is accepting parameter interface as what is E actually is. Just type switching. This is the library from Golang. So for a type switching, type assertion uh, also good if, for example, reader is implement by multiple interface. So you can use this. Does SRC it's implement interface write to or reader from to check again. Function type are bridges to interface, something like this. This is the basic Golang router API handling. The handler is the interface that have serve HTTP, something like this. And Golang have type handler func. And with this, Golang have something like this. That's why to implement the HTTP handler, you can use this func. Create only one func that have response writer and HTTP request. We going to recursion. Recursion is basically why I think this is wrong. I'm gonna show you the image instead. Okay, I'm gonna show you this. This is the Fibonacci, right? All you guys know, Fn equal Fn minus 1 plus Fn minus 2. So basically, a sequence that actually comes from the sum from two previous numbers, something like that. In recursion, you need to have two type, the base type and the recursion type. The part, the base part and the recursion part. For example, let's try Fibonacci. For example, Fibonacci. So if you see in here, Fibonacci is implemented something like this, right? It's you guys, oh, I'm sure know. Because Golang have two value, you can implement something like this in Golang. It's very simple. But the other language is going to be really, really hard. If you see the iteration, the recursive model for not model implementation is going to be something like this. It's really simple. That's why recursion is used sometimes not for performance reason. Recursion is used for elegant reason, because if you see this, is actually not very far from this. Maybe from this, not very far from this, right? You can still see here, but because of Golang have multiple value, multiple assignment, is actually not really difference the elegance in Golang. Also, you can use something like this, because in Golang there's three part, right? This for loop, and this for the condition, and this for the something that being called lastly. So you can use this. So I first and second, 0, 0, and 1, E less than this, and put E first and second, E plus 1, put here, second, and then first and second. It's actually the same with this. That's recurring. That's recurrence. If you see in the codes, there's two type in the two part. This is important, because if you falsely implement the close the base part, your code is gonna iterate indefinitely. So be careful about this. But in Golang, recurring is not performance. So if you can use iteration, use iteration. Another use of recursion is in divide and conquer. Divide and conquer algorithm use recursion. For example, this divide and conquer divide a problem into smaller size subproblem recursively, and conquer each problem separately, and then combine the result. Something like that. For example, Tower of Hanoi. Something like this, Tower of Hanoi. Every disk is stacked on top of disks that are strictly larger than it. These are moved one at a time from the top of one tower to top of another, and they can be placed anywhere other than 3 tower. Additionally, these always be stuck on empty tower or on top of larger disks. The goal of the puzzle is to, by a sequence of this move, end up with the disk stacked on some other tower. For example, this is A, B, C. We want to put from tower A the disk to tower B, and we have another tower C. How to do that? If we have only one disk, we just put this from A to B. The problem is what happens if we have multiple disks, right? We can solve Tower Hanoi something like this. Which one, Tower Hanoi? Do I implement Tower Hanoi or not? Wait. Oh yeah, something like this. The best part, the best part is when the disk only one. So just move from point A to point B. And then what happen if multiple, because you can stack smaller disks, you can stack larger disks on top of smaller disks. You need to put to another disk first, and then put something like this. You need to put n-1 from A to C, and then put another to B. The other part is something like this. So if you try to test, it's going to be something like this, from A to B with auxiliary tower C. Next, another implementation of divide and conquer is quicksort. In quicksort, in quicksort, the divide process is pick a pivot element, and then all number lower than this pivot is put on the left or on the lower part, and higher put in the then pivot higher part, and then both part is being conquered separately. After that, combine the value. But in quicksort, because of process conquer is also combining, there's no basic logic. They only combining the value. The implementation is something like this. Quicksort, which is quicksort. Something like this. Less, more. The choosing of pivot is different. The simplest one is the highest index, and the highest index the lowest index. Some other is 3 median, so get the highest, the lowest, and the median, and pick the highest from those 3 value, and just choose randomly in the index randomly. I use this the highest value for the pipe, the highest index for my pipe, for my pivot. I use to slice less and more, and on the partition process I use this. If lesser than sorry, if less, put in less than pivot. If more than pivot, put more. Wait, this is not really complete. I'm sorry. No, this is not part of the program. Now, and then just conquer each of the part separately and combining. Let's see the test. Short one. Yep, still holds. But the problem with this implementation is actually create 3 slices, right? So it would be nice if we just use 1 slice. Implementation something like this. So there's the difference between this implementation and this. In partition, there's in this partition process, there's swapping value. Oh, this is actually lesser than before. Let's put it value here and not put there. We use it something like this, right? And then the pivot is choose again, then again, then again, something like this. E plus 1. This is pivot index, and then just separate the value, the index. Or for this sort, just use this part. For this sort, just use this part, and this part is going to be smaller, smaller, and smaller. This is the test. We sort it. Okay. Quick sort. Okay, it's actually finished. Thank you for watching. Sorry if this is really basic. I'm a little bit wow with Dian. Dian is really complex, you know. And then oh man, I'm really simple. It's too simple. But thank you for the time.
Yeah, thank you so
Please,
much, Bilal, for the presentation. It's actually very detailed, and yeah, it was actually very detailed into every single details of Go features, basic features. So I think people the audience would have a lot of questions, but I don't think we have a lot of time to address any of them. So could you just quickly flash your contacts or like Twitter so that folks can reach out to you if they are interested to ask you more questions or ask for materials from you?
okay.
Yeah.
This is my Twitter and my Instagram. I'm gonna put it. And this is my email.
Oh, all right. So let me just add those into a banner and add that in. Actually, let me just send in the comments. So yeah, folks, yeah. So the last presentation was very detailed. That's why we didn't have any time, unfortunately, for any questions. So, but yeah, you can reach Bilal through his Twitter or direct email. So yeah, thank you so much, Bilal, for your talks. That was awesome.
Thank
Yeah,
you.
and that should be all for today. Thank you so much, Bilal. Oh, and we have Dian who's just joined back. Yeah, thank you so much, folks, for joining in today, and thanks everyone else who has tuned in and listened to our awesome speakers as well. So yeah, I guess we shall call it a day. See you all next month. Bye.
Bye. Thank you guys. Thank you, Dian. Thank you, Stanley, and all.
Bye.